All right, section 11.3, we look at data distribution. So we're going to continue calculating different measures of center and spread. So that'd be mean, median, mode, standard deviation, or quartile range. But now we're actually going to look at how the data is distributed and be able to classify that. So a couple of definitions for this first example. We have mean and standard deviation. Both those should be prior knowledge here. The mean is the average of the data set. And then standard deviation is a measure of how far the values are spread out. One thing we want to add here to make sure, like we realize, is that mean is a measure of center, so it tells us how the data is centralized. On the other hand, standard deviation is a measure of spread, which you should already know that because that's how we define it. For example, one, it's just a prior knowledge problem. So they want to know what are the mean and standard deviation for the following data set. It's all calculator driven. So remember, we go to stat, edit, enter the data in. I already have all the data entered in for me. From there, you're going to go ahead and calculate. So we go stat, calc, 1var, and then go down to calculate. And it kicks all the data out. I'm going to go to the nearest tenth. So our mean would be 11.6. Our standard deviation looks like it would be 6.3. I want the 5-number summary. So our min would be 3, Q1 is 6, median is 12.5, Q3 15.5, and then our max would be 25. Last thing they're asking you on example 1 is make a box plot of the data. Remember, you do that using your 5-number summary. So we have our min at 3, Q1 is at 6, median is at 12.5, Q3 is 15.5, and then our max is 25. So you go ahead, connect the first two, box from 2 to 4, line through the middle one, connect the last two. Okay, so that would be our box plot. With a box plot, remember that each of these sections represents 25% of the data, and that the line in the middle is the median. So half your data is to the right of it, half your data to the left. But like I mentioned, that should all be prior knowledge. So that's example 1. Example 2 is where the new stuff starts coming into play. And for that, we're going to look at some definitions. So when you look at data distribution, more times than not, we could have a skewed distribution. And by definition, a skewed distribution is when it's going to be stretched out in either the positive or negative direction. Okay, so we're stretched out in one direction. So you look at your 3 pictures down here. And then symmetrical, obviously, is when the distribution has a shape that is symmetrical. Okay, it's roughly the same. So mean, median, mode are all about in the middle. This is what we're looking at right here. Okay, so you have 3 options for data distribution that we're going to look at. You have skewed left, you have symmetric, and you have skewed right. For skewed left, our tail, okay, or the low end is on the left. Okay, so if we're skewed left, you have a low end on the left. Another thing you need to be able to do is realize that if my mean is left of the median, we're going to be skewed left as well. Okay, so whenever we're looking for skewed left or right, you're always comparing the mean. If the mean is to the left, skewed left. If the mean is to the right, then it would be skewed right. Okay. From the graph, you could also tell that it's skewed right because we have our low end on the right. Okay, so if our low end or tail is on the right, we could say it's skewed right. Symmetric, like I said in the definition, just means that it's like perfect. Okay, like you could flip it over. It's symmetrical. Your mean, median, and mode are pretty much all right down the middle. The other big thing from here is to realize measures of center and spread. So you're going to have 2 options for measure of center. You're going to have mean and median, the 2 options there. And then spread is either standard deviation or interquartile range. If you are skewed left or right, should be a T in here. If you are skewed left or right, so skewed is going to go with median and IQR. Okay, those two are always tied together. If we are symmetric, we're going with standard deviation and mean. Okay, so again, a lot of definitions and facts that you have to remember. That's just something you're going to have to be able to do here. So moving on, looking at example 2, they want to know which measures would you use for this. So they walk us through a process where the first step is to make a histogram. So remember, a histogram is going to be that bar chart. Okay, so you have the bar chart going on. They give you the intervals to use here. You need to make sure that they're labeled clear at the bottom. I should have done a better job with it, but the first one's 1 to 5, next one's 6 to 10, so on and so forth. Go ahead and make that chart. From there, they want you to describe the distribution. Well, if I were to draw a curve in here, like just touching the tops of each of these, I have a long tail on the left-hand side. Since our tail is on the left-hand side, we're going to say that it is skewed left. I know it's skewed one way or another because it isn't symmetrical. Okay, and since it isn't symmetrical at all, we're looking for which way is the long tail on. Long tail is on the left, or the low end is on the left, skewed left. For C, they want you to determine mean, median, and mode, and then I went ahead and found min, Q1, Q3, and max. That's all calculator right there. Okay, so you're just plugging it into your calculator. For D, standard deviation, IQR, and range of the data, you're just calculator again. So standard deviation comes straight from it. Remember, IQR is Q3 minus Q1. And then the range is going to be max minus min. For E, they want to know which measure of center is best and explain. Well, if you have any skewed data at all, it's going to be median. And then if you're doing the median for your center, it has to be IQR for the spread. Okay, so median and IQR are tied together directly. Mean and standard deviation are tied together as well. Okay, so that's example 2. You can do the try-its on your own. Another definition that we have is normal distribution. So normal distribution is going to be a bell-shaped curve. It's similar to symmetrical, but not exactly the same. Normal distribution has to be this curve right here. Okay, so you have to have a peak in the middle, and then it has to tail off at each end. Symmetrical could also be like anything that's like mirrors itself around the middle. This one's special though because the peak, the high point, is in the middle. For normal distribution, okay, so anything that's symmetrical or normal, we're going to say that the mean is our best measure of center, and then we know that mean goes with standard deviation. So example 3, they give you some scenarios, and then they go into detail why they're normal distribution or not. So you look at the heights of people in a large group, they give the graph right there. If you were to draw your curve in, we would have the peak in the middle and tails at each end. So since you have the peak in the middle, tails at each end, it is symmetrical. We're going to say that's normal distribution. Okay. So it is symmetrical, but the reason it's a special symmetrical normal distribution is because the peak is in the middle. For B, they give you the probability of landing on each of 8 equal parts of a spinner. This is not normally distributed because if you look at it, there's no peak in the middle. Each outcome has the same probability occurring. It's no good. Okay, example 3, they give you the scores on a test. Well, if you were to draw a curve in, okay, so I start low, go up, come back down. The data they gave us here is actually skewed left. And if you think about that, if you were to list all the scores out, typically less people do bad on quizzes than those that get like B minuses or higher. Okay, so since that's the representation for our data here, we would say it is skewed left. Remember, normal distribution would have the peak in the middle. D, number of children in a family. Okay, so if I were to draw my curve in here, obviously you have a low end on the right-hand side. So since it's not symmetrical and you have a low end on the right, we would consider this to be skewed right. All right, example 4, they want us to do this, so classify the data without even using a calculator, or not a calculator, but a graph. So you're going to go through this. You're going to run the analysis using the calculator. So that means just plug all this into the list, and then go stat calc 1 var. So doing that, you get all this information right here. Okay. Next thing you want to do to determine the shape of it is compare the mean and the median. Okay. Remember, mean always goes first. So with this, since our mean is less than, okay, so look at this, mean, median. Since our mean is left of the median, I'm going to go ahead and say that it is skewed left. Okay, reason being, mean less than median. From there, we want to determine our best measure of spread and center. So since it is skewed tells us that the center would be median. And then from there, median is always tied with IQR. And that's it for section 11.3. 11.3 can be a little weird, but with practice, you'll become good at it.